is Andres, and I will be talking about the Knapsack Dynamic Programming algorithm. Sorry for I don't know if you guys can hear the lightning. Um, but yeah, so I'll try to do this the best way I can, and I've decided to make, I guess, like a little scenario, um, so you guys can probably, and to help me understand it better too. So here we go. So it's the summer of 2020, and you being a college student, just finished with finals, but everyone's talking about this new store. It's everywhere. It's in the news. All your friends are talking about it. You, being a curious person, decide to check out this store. You find out that they're that they sell limited editions food and snacks and beverages. Basically, limited edition stuff, and that's and they're new. So they have some good things about them. They're eco-friendly, so they don't use any paper or plastic. Good for the environment, that really puts them out there. And they have the lowest prices you like in town, and and it's crazy low. They're beating out their competitors. The bad thing is, since they're new, they don't have many options. And to help and to make sure that every customer gets stuff, they have this rule. They have one bag per customer that they provide, but it has a weight limit on it. So they do this so that, like a whole bunch of people, they see a lot of stuff on sale. They want to just buy everything or buy as much as they can. So they do that so everyone has a chance to get that stuff. And so people are going crazy and they're trying to figure this out, like not trying to exceed the weight limit, but at the same time trying to get the best value for their dollar. So, uh, so the company decides to help out the customers a bit, and they decide to use the Knapsack Dynamic Programming algorithm to to help the customers out and get their best value for their dollar. And what this basically is, given a set of items, each with a weight and a value, you determine the number of each items to include in the collection. So that the total weight is less than or equal to the given limit, and the total value is as large as possible. So they do this to help the customer out, and they don't want their store to, to like not to keep the trend that it's on. So yeah, here I'll be describing the Knapsack Dynamic Programming algorithm that this new grocery store is implementing to help its customers get their best value. Um, so this is my second take. The first one actually didn't write anything down before and actually went through the whole thing as like me writing it down first, and it was a really long video. So I already did all the work, and I'll just to cut down on a lot of time. I'll just be explaining each step as I go. So right here, as you can see, we have four items. Item one, we have the Star Wars gummies. I'll probably zoom in a bit. Yeah, Star Wars gummies. Item two, we got Pokemon cereal. Item three, we have Infinity Gauntlet cookies. And then item four, we have Baby Yoda cereal. You can see each one has a weight and a cost. Item two, weight 2, cost 3. Item 3 weighs 4 pounds, costs $4, and item 4 weighs 2 pounds and costs $1. And we have the capacity, the bag that the grocery store is giving us, 10 pounds to limit our purchases. So a lot of people get a lot of so a lot of people have a chance of getting stuff. So step one, we create a two-dimensional array, and so it would be f sub I of j, and the size would be the capacity plus 1 and the number of items plus 1. So as you can see here, j, which is this top row, This will be J, which is the capacity plus 1, which would be 11. As you can see, 0 through 10 made it 11. And then right here on the side is the items plus 1, which is 0 through 4, which is 5. And you want to fill this first column and first row up. You want to set it all to 0. So yeah, as you can see here, most of this is already filled out, and I'll just be going through. Oh shoot. Okay, so I'll just be going through how I got this answer. And yeah, as you can see, the answer already is $10, but I'll be explaining that. So what you want to do is, so this f sub I of j is just basically this table. So if j, which is right here, you can see this capacity, minus the weight is greater than or equal to 0, you want to do the max of f sub I minus 1 of j and the value or the cost plus f sub I minus 1 and then j minus the weight. So the max, either of these two, you take the max and then you would use that and put it in the table if the capacity minus the weight is greater than or equal to 0. But if it's less than 0, you just do this this equation here at f sub I minus 1 and then just j. So as you can see here, we're starting with item 1, and the weight is 1, cost is 2, value 2, and then j is 1. And so so step 1 is check the capacity minus the weight, which here is just j. Let's just call it j. J minus the weight is 1 minus 1 is 0. So 0 is equal to 0. So we do this first max. Well, we do this first equation here, and we find the max. We take the max of either of these two. So as you can see here, we got f sub I minus 1, which I is now 1, and j is 1 here. And then we take the value, which is 2. We just drag all that down. f sub I minus 1 is 1, and then j minus the weight is 1 minus 1, which is 0. So we have 2 plus f of 0, 0. So 2, and then we on this other side we have f sub 0 of 1. So we go back over here and check. F sub 0 of 1 is 0, and f sub 0 of 0 is 0. So 2 plus 0 is 2, so we would put 2 in f sub 1 of 1, and then we increment j. So now the only thing that changes here is j. We're still on item number 1. So this is basically the inner loop of j, and we'll just be hopping through j here, just going until it hits 10, and then inner loop ends. We increment I, which is the outer loop. So I now, I'll get to that in a little bit, but we're just focusing on the inner loop here, which is at j. So the only thing that changes here is the 2. Oh, it's j, which is now goes to 2. 2 minus 1 is 1, so now it is still greater than 0, so we still do the max between these two, and the only thing that changes is the j. So we get f of 0 of 2 is, if I go back up here and check, 0 of 2 is 2. I mean, it's 0 of 2 is 0. You can see how I put 0, and then you get 2 plus f sub 0 of 1. And as you can go up here, f sub 0 of 1 is 0. So still got 2 plus 0 is 2. So 2 is greater than 0, so we put 2 in f sub 1 of 2. And we increment j. So now j is 3, and again, always the first step is to check j minus the weight. And now it's 3 minus 1, which is 2. And the only thing that changes is j. 3 here, f sub 0 of 3 is 0. If we check, we drag 2 all the way down. F sub 1 minus 1 is 0. 3 minus 1 is 2. If we check, since f sub I minus 1 does not change, As you can see, it's always going to be f sub 0, and for both of them, so f sub 0 will always be this. So we're basically just working with zeros. So so right here, this 2 will always be 2 plus 0. Since that j is the only thing changing, it'll just be going all the way until this one hits 10, which j hits 10, and that way it won't be. So that's why, as you can see here in the first row, 2's don't change, because it'll always be 2 plus 0. Since we're just working with that first row, we just be moving through that, just be getting 2 plus 0 the whole time. So that's why 2 is all the way around, all the way across that first row of I. So I'll just be moving on to item 2. So item 2 here, we got, so now we hit 10, j hits 10, we exit out of the inner loop, the outer loop increments I. So now I is 2, which is item number 2. Weight changes, weight is now 2, the value is 3, and j goes back to 1, as you can see here. Item 2, weight 2, and the value is 3. So yeah, so now we do j minus the weight, which the weight is now 2. J is 1. So in this case, we get a negative number. So now this negative number is less than 0. So we do that second equation, f sub I minus 1 of j. So, which is f sub 2 minus 1 sub 1. So it would be f sub 1 of 1. And if we go back up here and check, f sub 1 of 1 is 2. So we put 2 in f sub 2 of 1. And then we increment j plus plus. And then the only thing that changes here is 2, which is this j. And step 1 is always check. So now it's 2 minus 2 is now equal to 0. So we go back to that first equation, getting the max value between these two. F sub I at minus 1, I is now 2, so it would be f sub 2 minus 1, which is f sub 1 of 2, which is regular j. If we go back up here and check, that is 2. F sub 1 of 2, 2. And then right here, we just drag down the 2, which is the value, and then f sub 1 minus 1 is, f sub 1 minus 1 is 0. Oh, sorry, I'm on the wrong one. Yeah, so now 0. F sub 2 minus 1 is 1. We bring down j. It's now 2. We bring down the value, which is 3. Now I is still 2, minus 1. J minus the weight is 2 minus 2, which is 0. So now we check these. F sub 1 of 2 is 2. We bring this 3 down, which is the value. And then f sub 1 of 0 is 0. So you can see here, f sub 1 of 0 is 0. Yeah. So now, so we do 3 plus 0 is 3. So 3 is greater than 2. So we put 3 in f of 2 of 2. Then we increment j. J is now 3. Then we do check. 3 minus 2 is 1. 1 is greater than 0, so we find the max value, and the only thing that changes is this j. So we now check f sub 1 of 3, which is 2, and f sub 1 of 1, which is 2. So you can see here, 1 of 3 is 2, and 1 of 2 is 2. Yeah, f sub 1 of 1, and f sub 1 of 3. So 3 plus 2 is 5, so now we get a new number. 5 is greater than 2, so we put 5 in 2 of 3. See, 2 of 3 is 5. So as I'll explain one more, then I'll explain how I got the rest. So now j is 4. So we check 4 minus 2 is 2. So 2 is still greater than 0, so we find the max value between these two equations. Only thing that changes is the j here. So f minus 2 is 2, so f sub 1 of 2 and f sub 1 of 4. So we check these. F sub 1 of 4 is 2 and f sub 1 of 2 is 2. So they're both 2. So yeah, so here we get 2, and then we get 3 plus 2 is 5 again. And so we put 5 and 2 and f sub 2 of 4. Then we increment j, so you can see f sub 2 of 4, it's 5. So as you can see, or as you can tell, we probably have a pattern going on here. Since now, since whenever we check j minus the weight is always going to be greater than 0, we're always going to do, for the rest of j on this loop, the rest of these are going to be 5, as we're always going to do the max value, and the only thing changing is the j. And since the i doesn't change at all, as you can see here, I is always going to be 2. Yeah, I doesn't change, so the only thing changing is that j. So it's always going to be f sub 1 of j. Same here, f sub 1 of j minus the weight. So we're always going to be in this first row here, f sub 1. So we're always going to be working with these 2's. So it's always going to be that value plus 2 for the rest of these, which is always going to be 5 until we exit out of this inner loop and we increment we increment I. So now I is equal to 3. I'm hoping I'm explaining this right, or I'm hoping that you guys understand. I know I'm explaining this really weird. As I mentioned before, I did a video where I actually went through all these, like I actually wrote them down, and I thought that'd be way better, but it ended up being a really long video. And it's like kind of like a movie-long video of me explaining this algorithm, and I didn't think you guys would want to sit through all that, so I just took what I wrote and I'm explaining it as I go on. So now we jump out of that j hit 10. Now I'll pretend I did the rest of this, incremented this 5 more times, went through it, got 5 as the max value, because as I explained, we're just messing with that j, and since f sub 1 is always going to be, it's always going to be f sub 1, we're always going to be working with that row. So none of the values are actually changing. So that's why it's always going to be 3 plus 2, 5, and then 2. So, but 5 is always going to be greater than 2, so we're always going to put 5 in that spot until we exit that inner loop. And then we increment the outer loop, which is I. Items, we move to another item, which is now item 3, with a weight of 4, a value of 4, and then this j goes back to 1. So as we check here, j minus the weight is now 1 minus 4, and we get a negative 3. So negative 3 is less than 0, so we do that second equation, f sub I of 1, and I is now 3. So it'll be 3 minus 1, which is now f sub 2, and j is 1. So we go back up to our 2D array, and we get f sub 2 of 1. F sub 2 of 1 is 2. So we put 2 in f sub 3 of 1. And we increment j, we check again, j is now 2, 2 minus the weight is 2 minus 4, now we still get a negative number. We still get a negative number of negative 2, negative 2 is still less than 0, so we do f sub I of minus 1, which is not going to change in this case, f sub 3 minus 1, which is f sub 2, and j is 2, so we check f sub 2 of 2, which I'll just show you, f sub 2 of 2 is 3. So we put 3 in, I lost my place. We put 3 in f sub 3 of 2. And we increment j. It's still going to be a negative. 3 minus 4 is negative 1. So we do that second equation again. The only thing changing now is the j. So it'll be f sub 2 of 3. We'll go back up here and check. F sub 2 of 3 is 5. So we're going to put that 5 in F sub 3 of 3. And I'm just getting these by I and J. This first one's I, second one's J. So in this loop, until we break out of this inner loop and we increment I again, the only thing we're going to be changing is this J right here. Oops, sorry about that. So now we increment J. J is now 4. 4 minus 4 is 0. So if it's equal to 0 or greater than 0, we do the max between these two equations. So now f sub I minus 1 is still going to, I is not going to change, so it's still going to be f sub 2. J is now 4. The value here is 4. We bring all that down. We check J minus the weight, which we already did. 4 minus 4 is 0. This one doesn't change, I doesn't change, so we'd be checking f sub 2 of 4 and f sub 2 of 0. So f sub 2 of 4, f sub 2 of 4 is 5, and f sub 2 of 0 is 0. Here you go. So it'd be 0, and this would be 5. So 4 plus 0 is 4. So 5 is greater than 4, so we put 5 and f sub 3 of 4, and then j plus plus. So now j is 5. 5 minus 4, which the weight is still 4, is equal to 1, which is greater than 0. So now we do the same process again. The only thing that changes here is the 5. Everything else stays the same. 5 minus 4 is 1. So we do 5 sub 2 of f sub 2 of 5 and f sub 2 of 1. We bring this 4 all the way down. So f sub 2 of, we can check that real quick. F sub 2 of 4 is 5. So we put this 5 here. And f sub 2 of 1, here we go, 2 of 1 is 2. Yeah, so 4 plus 2 is 6, and then we get 5 for f sub 2 of 5. So 6 is greater than 5, so we put 6 and f sub 3 of 5, as you can see up here. F sub 3 of 5, 6. Then we increment j. So j is now going to be 6. So j is the only thing that changes. We still have to check. That's our number 1. Step number 1 always. We check. So j minus the weight. 6 minus 4 is 2. 2 is still greater than 0. So if it's greater than 0, we do the max. We choose the max value between these two. And right here, as I mentioned before, j is the only thing that changes. So we're just changing the j here. So it'll be f sub 2 of 6, which is, we'll check that in a bit. We bring down the value. Value doesn't change. I doesn't change, so it'll be still f sub 2. 6 minus 4 is 2, so we'll be checking f sub 2 of 6 and f sub 2 of 2. So f sub 2 of 2 is 3, and f sub 2 of 6 is 5. As you can see down here, that's what we did. 5 and 3. So we got 4 plus 3 equals 7. 7 is greater than 5, so we put 7 and f sub 3 of 6. Put 7 and f sub 3 of 6. 7. So now we increment j to 8. So j minus the weight. Weight stays the same. We're still on item number 3. 8 minus 4 is 4. 4 is still greater than 0. So we do the max between these two equations. So j is the only thing that changes here. F sub 2 of 8. And then 4 still the same value. Bring all that down. This stays the same, f sub 2, I doesn't change, still on item number 2. The only thing changes here is a j. 8 minus 4 is 4, so it would be f sub 2 of 8 and f sub 2 of 4 that we're checking. So f sub 2 of 8 is 5 and f sub 2 of 4 is 5. So they're both going to be 5. So we do 4 plus 5 equals 9, and 9 is greater than 5. Then we choose the max values between these two, which is 9. So we put 9 in f sub 3 of 8. F sub 3 of 8. So as you can probably tell, and I'll explain it, the rest of these, well, these other two are going to be 9 as well, as now we have entered, we're working with f sub 2, and now j is big enough to where it's going to be just these 5s. I'll explain a little bit better. I'll show you an example. So here, the only thing changing here is this j. We're always still going to be on f sub 2. So now that we hit, like right here, j is 4 now, it only goes up. So it's always going to be, so for the rest of the, so for if j is, so if we increment j, which is 9, be f sub 2 of 9, which would be still be 5, and 4 plus f sub 2 of 5, which is 5, so it'll be 9. So we choose the max value between 5 and 9 again, it'll be 9. And then same goes for 10. So on this next one, I just, we hit 10, so I just filled these in, just to save a little bit of time. But I hope you understand why these two are still the same. So now we exit that inner loop, j, and because j, once j hits 10, after 10, we exit the inner loop, and then we increment I, the outer loop, which is our items. So now we're on to our last item, item 4, and then j resets, j is back to 1, and I'll show you guys here. I actually did all of these. These are probably the most exciting. So now we're item number 4, and so the weight changes and the value changes. As you can see here, weight is 2 and the value is 1. Check item 4 is that Baby Yoda cereal. The weight is 2 and the cost is, the value is 1. So now we do step 1. We check j minus the weight, 1 minus negative 2, which is negative 1 is less than 0. So we do f sub I minus 1 of j, which is I is 4, so we do 4 minus 1, which is 3. So we do f sub 3 of j, which is 1. So we check f sub 3 of 1. So f sub 3 of 1 is 2. So we would put 2 and f sub 4 of 1. Then we increment j. So now j is 2. 2 minus 2 is 0. Since if 0 is greater than or equal to, if this equation is greater than or equal to 0, we do the max. We take the max value between these two equations. So now I changes here. I is 4 and j is 2. And the value is 1 now. We bring all that down. Right here is the equation we did up there. 2 minus 2, j minus the weight, which is 0. So we check f sub 3 of 2 and f sub 3 of 0, which ends up being 3. F sub 3 of 0 is 0. So we do 1 plus 0 is 1. 3 is greater than 1. So we there you go. So we put 3 in f sub 4 of 2. As you can see here, we incremented j. J is now 3. J is now 3. 3 minus 2 is 1. 1 is greater than 0, so we take the max value between these two. equations. The only thing changing here is the j, which is now 3, so we check f sub 3 of 3 is 5, and f sub 3 of 1 is now 2, so we do 1 plus 2 is 3. 5 is still greater than 3. 5 is greater than 3, so we put 5 and f sub 4 of 3. Yeah, so as you can see here, right here you go. F sub 4 of 2 is 3. Whoa, no, my bad. F sub 4 of 3 is 5. Yeah, so now we increment j. J is now 4, my bad. So 4 minus 2 is 2. The only thing changing is 2 is still greater than 0, so we take the max value between these two functions, these two equations. The only thing changing from before is j is now 4. I is still the same, so we still get that f sub 3 for as the first part as I for both of them. And j is the only thing changing. So we check f sub 3 of 4, which is 5, and then f sub 3 of 2, which is 3. And yet again, we get 1 plus 3 is 4, but 5 is greater than 4, so we put 5 in f sub 4 of 4. So you can see up here we get f sub 4 of 4 is 5. So yeah, now we increment j to 5. J minus the weight. Weight stays the same. We're showing item number 4. 5 minus 2 is 3. 3 is greater than 0, so we take the max value of these two functions. F sub I still stays the same, which is 4. 4 minus 1 is 3. The only thing changing is j. J is now 5, so we check f sub 3 of 5, which ends up being 6, and f sub 3 of 3 ends up being 5. 5 plus 1 is 6, so right here they're both 6, so we put 6 in f sub 4 of 5. So f sub 4, 5, 6. Yeah, so now we're on 7. Increment j. J is now 7. We do step 1 again. We check j minus the weight. 7 minus 2 is 5. And now we do the max. We take the max value between these two equations. The only thing changing from before, j is now 7, so we check this first part, f sub 3 of 7. And right here we add 1 to f sub 3 of 5. Since we got right here 7 minus 2 because of that j minus the weight. So f sub 3 is 6, and f sub 3 of 7 is 9. So 1 plus 7 here is 1 plus 6 is 7. But since 9 is greater than 7, we would put 9 in f sub 4 of 7. F sub 4 of 7 is 9. Now we get here. So j, we increment j. J is now 8. We check j minus the weight. 8 minus 2 is 6. 6 is greater than 0, so we take the max value out of these two equations. The only thing changing from before, as I mentioned, is j. So now we check f sub 3 of 8 is 9. F sub 3 of 6 is now 7. So we do 1 plus 7 is 8, but 9 is greater than 8, so we put 9 in f sub 4 of 8. F sub 4 of 8. So, and now we increment j. J is now 9. So 9 minus the weight is 9 minus 2 is equal to 7. So 7 is greater than 0, so we take the max value between these two equations. And the only thing changing from before, I still stays the same. We're still on item number 1. So j is now 9. So we do f sub 3 of 9, which ends up being 9, and f sub 3 of 7, which ends up being 9. As you can see up here, f sub 3 of 7 and f sub 3 of 9. Yeah, So we get 9 plus 1 is 10. So we put 10 is greater than 9. So we put 10 in f sub not 4 of 9. F sub 4 of 9 is 10. So yeah, so as I mentioned before here, we're working with this row right here, f sub 3. And since both of our j's are now up to these 9s, it won't affect this next one. The next one would still be 10 because we still get 9 plus 1 because we'd still be working with these numbers from before. So that's why I didn't, as you can tell, I didn't do the last one. But if we did increment, well, I mean, we do have to do it, but I saved a little bit of time, so I just, instead of writing, I'll just explain it. We do increment j, which is now 10, which would be 10 minus 2, would equal to 3. 3 is greater, 10, my bad, 10 minus 2 would equal to 8, not 3. The only thing changing would be j would equal to 10, which would still be 9. And then right here, 10 minus 2 would be 8, would still be 9. So it would be 1 plus 9, it would be 10. So we still end up putting on f sub 4 of 10 will be 10. So yeah, so now we're done. We exit out of the inner loop. And the outer loop, we exit out too because we only have 4 items. So the outcome would be right here, this last one. So it'd be $10. $10 would be the max amount of money that you would spend without with meeting the capacity and not without exceeding the capacity is what I mean. Yeah, so that's just, hope I explained that really well. As I mentioned before, this video was much longer. I just condensed, I just read through all this. And so yeah, you should see the brute force algorithm on the knapsack problem. It's crazy. But yeah, so $10. So whenever you would do this algorithm, you would always look right here in this last little box. That'd be your max value that you'd get without exceeding the capacity limit. Yeah, so this algorithm doesn't tell you what items, and that's, I guess, for the company that's good. The company doesn't give you like the full information to the customers. They just give you like the value amount and then let the customers figure out the rest. So they're still bringing customers in, helping them out a bit, but at the same time not giving them like everything. So they have to put a little bit of the work in, and so the customers are happy now, and everybody's getting all these goods. I would really like this Baby Yoda cereal. That looks pretty good. So yeah, so hopefully I explained this well, and this is my Knapsack Dynamic Programming algorithm. Thank you for watching.